All right, let's talking about the most important decision, architecture decision that maybe you can do when you are doing a system design, and that's come from that data modeling. And in this case, we will see the trade-off about relational versus document model. And I will be honest with you. Actually, this is not only a just decision that maybe in the few months you can do a refactoring. That will follow you within a long term, and it will will affect the way that you will be and scalability in your application, and actually how fast your thing can move, and the way that maybe you can create your application to consume the data. And actually not only it will affect the application, the transactional part, actually it could be affect that the data engineer team that needs to be consume the data and propagate the data in multiple analytical service. So generating a mistake here, actually it will be the worst decision that maybe you can take in this part. And in this video, I want to share you not only just the description or the weakness. In this video, I want to show you why it's important to have a strong knowledge about the context of your business. What is the API design that you will do? What is the number of the requests that you can expect that get versus the post? You will have an even the consistency. You will have a query complex. What will be the capability that you expect to do? You will handle shardings. So that is the question that you have to resolve first. And then you have to decide which model you want to use. Actually, there is not a single solution. All the cases, it will need to have a handle the disadvantage. But you have to take what will design, it will be have more advantage in your context decision. So that's it. So we can go ahead with the video. So maybe we can first talking about the relational model. The relational model, maybe we can have examples like Postgres, MariaDB, or MySQL, SQLite. So they are relational model, and they are composed by tables that also is called relations, or rows that is called tuples, right? So that's come from like this spreadsheet maybe that is come have a relation between of the tables using joins, right? And usually have enough foreign keys to define it, which is the structure of these multiple tables and what is the dependency that have this, right? So that's it. Actually, is knowledge this relation model because it's a cricket schema. It's you need to first define it, which is the number of the columns that a table could have, and it will be the same number of the columns for all the rows that have this table. So this is a rigid schema, right? I mean, with that. So, and we have to know that there are multiple joins that you can do. Actually, the left joins, right joins. If you have a small experience with relational model, you understand what I mean when I said when left joins, because you only create a relationship with two tables, and you only need to get some of part of this relation, right? When you are generating a merge of these multiple tables, right? So, so I want to tell you that there are strengths. Okay, so in this case, the strength maybe could be the many-to-one relationship and many-to-many. I don't say that there is not a strength one-to-many, because later we will talking about there is an advantage in the document model when we are talking about one-to-many, but I will explain it later. In this case, only talking about there are strengths with many-to-one and many-to-many. And when we are talking about those relationships, that means that there are many rows that can be referred to a single row to another table. It's like imagine that you have a table that you have a users that have several rows there of user, right? But there could be several users that have the same relationship with a single row of another table. Like, for example, multiple users can born in the same city or the same country. So in this case, have the same reference with the table of the, I don't know, countries. So that's me when I said many-to-one. Many users can refer to the same country, right? And many-to-many relationship is like when you are working with a social network, right? There are multiple users that following other user, and users that can be following for other users. So it's like a many to many relationships, right? So many to many relationships usually need to have uh, two tables. I mean, right? Because that no, the tables that have the list of the user, and another table that need to have the relationship of this this user, right? So that means, and the rational model is very strange of that. Um, that's all. And when we are working with relational model, we are working with normalization. That's mean that instead to have, for example, we're talking about that we're working with multiple tables, multiple reference, and the reference of multiple tables, you are usually use an ID. An ID could be an integer, right? That is could be indexes. When I say indexes, because the idea is that the table could have multiple indexes that when you want to search something or search a value of the column, it will be faster if this column is indexes. And the index is only is a way to create a replication of the table for some ways to explaining. Okay, you have a table that you have an index of the, for example, by name. So you will have a replicate of this table to only have the, for each name, it will have the relationship with the position of the main table that you want to find the real row. Imagine that you have the real table with the multiple rows, right? And you have an index by name. This index, when you want to find, when you want to search by name, it will first will go to the this replication index, right, of this table, and it will find first by name, and then in this name it will find the position that it will finally find in the real table that have the main row, right? So that's mean with index. And when I say that normalization is come from that all the reference of the multiple tables or the joins that you want to have, right, come from that only indices, right? That come from usually integers, right? That's mean. And usually you don't need to work. For example, if I have a good example maybe here, right? It's like um, for example, here, if you have an issue, this is grown actually because this is normalized. You have a table that education, right? And you have a list of the institution, right? It's in a user A, user E. Okay, for example, maybe, right? If you want to have an okay, for example, here, right, you have a contact info, right? This is the table, and there is a reference with the user ID. And instead to have actually the name of the username here in the contact info, it's the preference is that maybe you can use the position of the user ID that you have on the table of the user. So you want, if you want to have the a table or the report of the, you want to display the username with the contact info, only you just to find the user using the user ID and the user table, the name, and finally to get the email using the same user ID. And the result, it will be um, the table, a report with the name of the user and the email, right? So that is the reason. That is the meaning when I said normalization. And actually, the advantage of to have the normalization is because you have a good grade performance. Because, for example, if you want to only update, you have a relationship with, for example, right, many to one. You have a huge number of the users that have a dependency with a single country because they're born in the same country. So if you want to update the country for all the user, only to need to you just update a single row in in a single table that is come from the table country, and you don't need to touch all the hue of number of the user because the country is normalized. So that is a reason that grad is have a good performance, and actually consistency, because you don't care that you don't need to worry that all the users it will be updated with the same name of the country, because it comes from the same data, right? So that is the advantage to have a normalization with the relational model. And usually, when you are working with relational model, you are working with in an application. You are working with an ORM that comes from object relational mapping. It's a library usually that provides to you a way to consume the database and be synchronized with the application code. So you don't know to you don't. The idea is to have to not to worry about how is the implementation of the tables or updated the table actually. So that is an advantage for advantage in a way to say, because obviously there are disadvantages, but the advantage of that, you don't need to worry about the implementation of the application database layer, right? That come from the ORM. But actually there are disadvantages that we will see together here. The first thing is that it will be reduced a boilerplate, because you don't need to worry about the part of the compose the tables, right? And there are query catching, because actually when you are working with multiple um, tables in the same application code or the same context or the same thread, maybe the ORM have a good algorithm or good implementation that not need to consume the table, because there are transactional, right? Transactional, when I say transactionally, because the change that you have in the code is only affect in the application layer, and not be affected in the real database, because it's like an draft it's like a draft way, right? It's like a draft site that you are working only in the application, and when you finally you complete the part of the application, it will be generating a commit, and when it's generated a commit, it will finally write on the disk that change that was accumulated in the application thread code, right? But I mean that the ORM usually take care the part of the query caching to not need to have to not call multiple times to the database, and it will handle it by this library, right? And actually, the advantage that maybe you can use it in this ORM is that it take care the part of the migration management. If you are working with object-oriented programming, when you are creating your object, it will generate an relationship with the tables with a multiple table actually, and when you are a developer and you are creating a new column, the ORM it will take care to create the new column, and actually it will have the correct type of the column, that the idea to be to match with the type of the object that you created in your application. That means when these libraries take care of the part of the migration management. Okay, but there are cons about that actually, because um, obviously you know that in this part that ORM take care all about database, but that database also need to be handled by in your code, because it's not the ORM is not enough intelligent to handle complex query or complex situation or edge cases that maybe you need to have. For example, consume a query, a complex query that maybe if you decided to use only ORMs or the layer that only provides this ORM to consume the data, it could be that it will be worse than if you do manually the SQL and query to get the data. So finally always it will be faster and good performance if you understand what is the language of SQL. So finally you have to write SQL in your code. So that is maybe the first cons that uh, many developers discuss about that. It's like why or this ORM, okay, it will help to you in some part, but finally you don't resolve the part of the complex query. You have to do something custom in your code, and finally it will be um, generate a mess, right? But okay, this is the cons that to use ORM, but there is advantage obviously, right? So maybe you need to have a manually complex query if you need it, and you have to take care or you have to worry about the n+1 query problem, because I know that there are ORMs that maybe take care this problem, but if you don't know how it's working your application or this library that you are trying to do, maybe you could generate this problem actually. So you have to take note about that. And well, the likely abstraction could generate a problem because you don't know what's happening internally when something is wrong or something is failing. So maybe in summary, maybe you can take the decision that you want to skip the part of ORM, and finally you prefer to have to generate a query. In my case, in my experience, when I have problem with the ORM, I prefer to use directly the query on the code because it will be is for me easier to understand what is happening, right? But that is a cons that you are working with ORMs, right? But relational model is not also happy. Actually, there are weaknesses that you have to take note, right? In this case, is relation with that I think that I say. Actually, the weaknesses come from when you are application developer, right, or software engineer. That you know that usually you are working with object-oriented programming, and the problem is that the first thing that there will be an impedance mismatch, right? That come from the idea is that if you are working with structures like an JSON with nested um, children's or properties that have arrays, right? And actually, that the idea of tables not much it's not like a one-to-one relationship, because actually um, you are working with JSONs, right? And then in another layer that is a database working with tables, table finally is trying to be composed using the part of the object. But that means that obviously there is an impedance mismatch, right? Because it's not a easy way to be the same object, right? We are talking about tables. In another side, we are talking about objects in the application code. That is the weakness, right? Because we will compare with document model. That for that reason I say that. Um, and for that reason, when there is this impedance mismatch, we are talking about that you need multiple tables and foreign keys, right? And need to be reference in between of them, joins, right? And that means, right? And there are inflexible migration, because actually, if tomorrow you created a column that is an integer, right? And later you want to be a varchar, you need to generate duplicate this column, and this column had to be converted to varchar. I mean, created with varchar, and finally you have to remove the column that is the original, right? And then you have to rename the column that is the varchar that finally rename of type, right? It's not it's inflexible, the migration, and actually this migration there is a cost, because for any huge change that you want to have in the database, it will generate an login and have a good, bad performance in the experience with the user, because when it's generating a migration, there will be a problem with the performance. Okay, so that is problem that you have to handle it. Okay, and actually, when you are doing a migration only to take the solution is because the idea is with that maybe you can generate an batching to do migration partially or duplicate whole table, and finally in a single moment you can um, do a switch, right? Uh, the change had to be instantly. right? So that is the idea when you are working with migration. But okay, that is another thing. And the problem is that the complex sharding when you are working with table, because when when you are working with sharding, you uh, usually is because you are have to duplicate the database, and there isn't a logic balancer that handled. There is a logic of the sharding using multiple databases, right? When you are working with sharding with a relational model. So if the databases, it will be divided, right, in multiple shardings, there will be expensive if you want to do an across sharding of queries. You want to create a query that across multiple sharding is very, very expensive. So you have to take note how you will generate this sharding. Usually it could be maybe um, the decision of a sharding come from the entity that you want to sharding to not have to do another a cross sharding. And when you are doing that, actually, it's like a long term, because actually you expect that in your future you don't need to do a cross sharding. But obviously, if you finally to do an cross sharding, you have to map in another database to not have to generate um, other problems in a query. But that is another problem that you are doing scalability with this relational model, right? I don't say that it's not, there is no way to do sharding, because yes, the possibility is there, but it depends of the context of the business. The other way to scale to do scalability with relational model is using the pattern of the master and slaves, right? You are growing vertical in a vertical CPU, but you generate replicates to have a read um, request, right, in another slave databases. But okay, there are multiple ways to do an scalability of relational model, and sharding is not an strange of this model. And when we are talking about the document models, we're talking about examples like an MongoDB that is very knowledge, right? Um, Very popular actually, MongoDB. And MongoDB is composed with documents. Documents is come from is usually used a BSON, right, or JSON, right? JSON is a structure like in this example, right, and is composed like a tree structure, right? And the idea of this kind of structure is that it's very flexibility, because you obviously you can nest and deep multiple objects here, and multiple types of data. So it's very flexible to data types and the structure actually. And okay, usually this structure is aligned with the object-oriented programming that you can expect to do when you are doing your application. So it will be easier to see um, in a single shoot what is the object that maybe you it was composed in the application, right? Because it's a one-to-one relationship, I mean, right? And usually in this case, the strength it could be that one-to-many relationships. Why? Because actually, in the case of the relational model, if you want to one-to-many relationships, you need to create another table, and you have to do an adjoins there, right? But in this case, no, it's not to do an multiple joins. Actually, in a single model, you can have all the children of the single property, right? So there is not strange that. But if you want to do many to one or many to many, obviously it will be very difficult to do it with this model, because you need to have another model and have to reference uh, itself, right? So it's not a good model that if you want to do an many to many or many to one, right? But yeah, there are strategies to handle it, obviously, right? But uh, but that is the weakness, right? If you compare with relational model, I said that, okay. And actually, it's easy sharding, right? Because MongoDB actually is created to do sharding, right? So because if you think about that, it's like a single item of this document model already have that data that is everything for to be consumed. So not need to have a joins, not need to have a relationship with multiple tables because everything is in a single item. So the challenge is very very easier, right? In the case of the relational model, the sharding impact multiple tables and had to be split in multiple databases. So it's complex, right? So that is the difference. And the next thing that when we are working with data document model, the idea is to have to work with this normalization that comes from that uh, you are working with duplicated data, right? You're not working with joins. If you're not working with joins, you don't working with integers indexes, right? It's like you don't need to refer to another item, another that document model. Everything is in a single model. So that um, said that if you have a list or item of users in this document model, all the users will have the country name in each document, right? And if you finally you need to do an updating of the countries of all the users, obviously that is the part that could be an expensive. But the good news is that if you want to consume a user, you don't need to do a join, so it will be faster than a relational model. So for that reason, actually, in this case, that the normalization actually in this case we can see in this chart because there is in a single shoot you can get everything instead of a relational read that you have to consume multiple joins, right? Is created for a schema on read actually, right? And the data localities mean that everything have in the same structure, right? So that is the idea to work with a document model. But not everything is happy actually, because there are weaknesses in this document model. And the first thing that there is a weak transaction. I know that MongoDB already support transaction, and MongoDB is trying to do the transaction that have on the relational model, but it's not as strange actually. That is not the idea actually of MongoDB. I know that there is the feature, but if you will doing multiple transaction and you need to a strong transaction and consistency, it's preferable to have to use a relational model if you decided to do if you need that. I mean, right? So you have to take note about that weakness and strengths. And no, I don't say that you can use MongoDB, but I said that you have to take note what is the major number of the advantage of these databases, and then you can choose which one it will fit better for you, right? Only that, okay? And yeah, there are weak join support. I know again that MongoDB also support joins, okay? But obviously, again, that is not the strange thing that maybe we can have in MongoDB. Again, if you you want to do it, yeah, you can do it, but it's not. It will be a worse performance if you prefer to do it with relational model. So again, if you will use a several number of joins, prefer to use relational model. That's it. And the problem is that if you have a large number of documents or items in this document model, it will be expensive to write or do an consistency of all the data, right? Actually, there is a potential inconsistency, right? Because you need to update everything. But that can maybe you can think that you can use MongoDB or document model to be updated with the eventual consistency, right? It's not could be a weakness. Maybe it's not something that maybe you can take care because you only have an take the advantage of the fast read, right? And you want to use this database because you already have a source of truth in another databases, and you have an queue to be updated this MongoDB, and you take care that eventual consistency because it's not usually to write this table. Okay, maybe you can go ahead with MongoDB. Maybe it's a good decision for you, right? But you have to take note that right. Maybe okay, maybe. I don't know what will be the application that you do. If you will do an application that all the APIs will need to always get everything of the data, and you not to have to get the partial data, right? Because if you want to partial of the data, maybe you want to work with the relational model. But if all the APIs always call and get all hold the structure of the document model, maybe it's better to use the document model, right? So that means, and and in general that is the difference, right? But we know that currently today relational model already support JSON indexes, like we have on MongoDB, and obviously document model already supports joins and schema validation, or and so yeah. Between of these model, obviously there are um, the solution okay, and maybe you don't need to have the document model if you have already the relational model, because the feature already supported on relational model, right? But there are disadvantages because it's not created for that. But obviously create another infrastructure to only to have a document model is expensive. So right, there are multiple um, factors that maybe you have to take note before to decide if you really need another token model or relational model. So first, I prefer to ask you several questions. First, if your database will have a huge number of the read requests and then write requests, right? And if you take care about the event consistency, right? If you need to take care of, if it doesn't worry about the event consistency, maybe we can go ahead with MongoDB, right? If you need a flexible structure because you are working with a marketplace with multiple products, multiple uh, uh, multiple kind of tropic, multiple type of products, like you are working with electronics, you are working with foods, so there are different metadata for each one, so you prefer to have an flexibility structure, and you focus to have an faster read, right? So you maybe go ahead with MongoDB. But if you have a stricter schema, you have to do multiple transactions in multiple you have multiple transactions in multiple times in multiple sites of the platform of the application. So maybe you prefer the benefit that maybe we can have with the transaction of the relational model, right? Or in some places on the application only you need to some piece of the data and not all the data, so prefer to have with relational model, right? And so that, but in this video only I want to show you um, all the context of the data models to take the final decision for you, right?